Camtasia's recording, record it 2 ways. Hey, everybody, we're going to continue with our lessons in statistics. This is Math 21 at College of the Sequoias, fall 2022. Last week, we covered 1.1 through 1.3, where we talked about what stats are and how we go about doing surveying and stuff like that. We're going to continue with that. So the first area I want to talk about is biases. This is 1.5 for anybody that's not in my course. I do all my chapter 1 homework together. But 1.5 is on biases. So these are pretty big. A bias is when you have a favor or inclination towards one group or choice over another. So a bias is favoring or having an inclination to choose one option, group, something like that, over other ones, over another. Over another, not another's. That doesn't make any sense. Another. And why this is bad is this can skew the results of your survey. Mess up your survey. And we talked about this a little bit last Tuesday. Like if you were wanting to know if fitness was good for people and you want to know what people thought, and you went to a gym and asked questions, your choice of who's in your survey favors people that are pro-exercise versus maybe the ordinary citizen. So that's an example of bias. There's a bunch of different types. And we're just going to cover them and talk about what we can do to avoid them. We mentioned last Tuesday convenient sampling. And this is where you pick your group based on convenience. An example of this would be a teacher just surveying their students. On a survey about students. You guys might make a perfect random sample. Well, probably not. But you might be a really good candidate if I added a few more for something not related to school. The reason why I would say that is most college students are younger, and you want to ask people of a wide variety of ranges. I know I do have people in the class that are over 25, probably some that are over 30 or 40. And so I have a couple, but mostly it leans towards the younger group. And so I'm going to have a bias based on age, just by the, or there, it's going to be favoring young, depending on the survey. That might be important. These are things I want to avoid and things you want to avoid too. So we talked about this on Tuesday. If you're wanting to survey people, survey at different times in different locations is a good option. That way you're getting a wide mix of people. You want to randomize who you talk to, pick every 6th person that walks by you, or something like that. There are other forms of bias that exist, and it's hard to skip some of them. One of these is called undercoverage bias. And this happens when, let me see if I can fix this so my hand's natural. There it goes. An undercoverage bias occurs when the proportion of each group in the population doesn't match the proportion in the sample. And that's a lot of words. Let me give you an example. It'll make much more sense. This happens a lot in politics. We have two major political parties, Democrat and Republican. But there are other parties. There is the Green Party, there is Libertarian, there's a couple others. And those other parties generally make up, around 5% of the population, maybe a little more, a little less. But usually when you survey, you end up only getting Democrats or Republicans. It's kind of, if I asked 100 people, I would be surprised if I've got 5 people that are not Democrat or Republican. So surveys tend to capture the Republicans and Democrats. But Libertarians, Green Party, other parties, Libertarian and Green Party are not. Spelled that kind of junky. Let me rewrite this. Libertarian. And that's not ideal, because then even though they may be a small group, they should have a voice. And so it's kind of hard to account for that. But it may lead to a bias that you may not even know when you're doing a survey. So it's kind of hard to account for this one, other than going out and looking for people in that group. But then you're not really having that random sampling that you want. I'll let you write this for a second, and then I'll turn the page. Okay. You need that back, just let me know. Okay, so another type is the non-response. I guarantee you we've all been a part of this, unless you are one of the rare persons in this world that every time you get a phone survey, you say, yes, I'd be happy to participate. Non-response is when participants don't want to respond. Let's see. There we go. Shows up a little better there. Shift the lighting, that might help too. Okay, so if you're out asking people questions on campus, they may be busy, they don't have time, that's another form of non-response. Phone calls, calling about surveys. Hey, do you have 3 minutes to answer a survey? A lot of people say no. I try to say yes if they say it's not going to take long and I'm not doing anything. If I'm watching TV, my wife likes to take enough breaks that we like, just let's take a 3-minute break, babe. because it's helpful. But a lot of people don't respond, and same thing with mail. You get surveys in the mail. Would you please fill this out? They have a way to minimize this. You can minimize non-response, minimize non-response bias by incentivizing participation. The male ones do this a lot. They have gotten smart. They'll send out $1 or $2 cash with the survey, with a pre-addressed stamped or pre-stamped addressed envelope, and you get to keep the money either way. A lot of people feel a little guilty if they keep the money and don't do the survey, especially when you can see it's 5 quick questions. It'll take you a minute of your time. So by throwing $1 in the envelope, it's going to cost them more money than just sending out empty surveys, but they're a lot more likely to get responses back. And so that's one way of doing it. If you're doing it in person, you could have, sodas or waters out, candies out, something like that, something to encourage them to stop and give you a moment of their time and do something like that. It happens all the time. Another way they do it is they offer callbacks. If you're busy now, can I call you later? Some of them actually ask. I've had people ask, and I said, yeah, I'm busy now, but I'll be free in 5 hours. Or I'll be busy, or I'll be free this evening. And they call in the evening. A lot of times they don't even ask. They just call back. Or someone else calls back. Gosh, I got a tickle in my throat. Other forms of bias is response bias. You said non-response. Here's response. Things that fall in this category: misrepresented information, which can include flat out lies, interview errors, where they just make a mistake and it skews the results of the interview, or a vested interest in one of the parties involved. And that includes the interview. Excuse me. So misrepresented information, stuff like that is, let me give you a perfect example. Back when there was big surveys or big fracking was in the news a couple of years ago, really big, people were fighting it. Fracking is where they do high pressure, I want to say water through the ground to loosen up oil and get it free. And some groups were upset about it. I received a call about fracking asking if I had a few moments of my time to take a survey, and I said yes. And it quickly became apparent by question 2 or 3 that the interviewer was definitely anti-fracking, because my options were for response, does fracking bother you? Does fracking bother you a lot? Does fracking bother you a little, or does fracking not bother you? Like almost every single answer was in a response, a negative about fracking. Whereas a better question that would be non-biased would be, are you aware of what fracking is? What are your feelings on it? Not prompting the person for what you want them to say. By saying, do you have negative feelings for it? You're kind of pushing for negative feelings. So it's better to ask them what they think rather than doing it. This often stems from a vested interest. A vested interest is where you care. This could be a car salesman doing a survey with people and asking about what people think about buying used cars versus new cars. Now, they may have the best intentions of doing a fair survey, but since they sell used cars, there's a good chance that they might subconsciously, at the least, either through inflection of tone of voice or something, indicate that they think that buying a used car is a better choice than buying a new car. And so having a vested interest, and that's what I mean by vested interest, you are invested in the outcome of the answer. If you're a car salesman, you want people to buy used cars, or I'm sorry, used car salesman. If you're a new car salesman at like a dealership, you don't want to buy new cars or used cars, you want to buy new. So you might play up new cars. And then there's just flat out errors. You make a mistake. It's kind of hard to give examples of that, but it happens. Some things you can do to help avoid this is making sure you phrase your questions well. So phrase the questions well. Trying to avoid prompting for a given response. That's one thing you can do. We'll say one. So making sure you do that. Sometimes you can't. You gotta give specific examples. Here's an example. I'll give the example first, and then say what we do to avoid it. Do you prefer Pepsi or Coke? Coca-Cola, we'll say. Use the official name. This might be important to you if you're doing it, if you don't want to include, say, off-brand or generic sodas. You don't want Shasta on the list. You don't want a generic cola on the list. You just want to compare Pepsi or Coca-Cola. And that might be the point of the survey. What happens here is if people don't have a inclination or don't have a preference, they often choose if the list is short, they choose the first one they heard. If the list is long and there's a lot of choices, they don't often remember the first one, they just say the last one. So what you could do is mix up the wording between people. Do you prefer Coca-Cola or Pepsi? So by alternating which one I'm saying first or last, I can try to avoid any bias that's generated for people that don't care, or you know what I mean? Hopefully you know what I mean. That's a good way to go about doing it. You can leave the field blank. And this comes with pros and cons. Open-ended questions. And closed questions. These two are closed questions. An open-ended question in this category would be, what type of cola do you prefer? And now they're not giving a choice A or B, they got to fill in the blank. This allows for their actual opinion. You're not prompting, giving them examples. Unless they actually ask. I mean, like if they don't know what cola means or soda. I deliberately used cola because that's what the drink is called. And like you generally don't call a Sprite a cola, it's a soda. Cola is very much a dark soda. So I use cola specifically. So you get more accurate results. Which is good. This is a pro. But you may get too many different types. Someone might say Pepsi, someone might say Diet Pepsi, someone might say Cherry Pepsi, someone might say Diet Cherry Pepsi. I can do the same thing with the Coca-Colas. Let's throw in Coke Zero and Pepsi Zero. And then same thing with generics. I could get 50 responses to this. And when you're trying to summarize the data by counting up each response, do I put Pepsi Zero and Diet Pepsi in their own categories? Do I care about diet versus regular, or can I just throw all the things that say Pepsi into a Pepsi category and just count it as that? So it leaves a little bit of a struggle on what you do with the data when you have open-ended questions, or can't. Sometimes it's not too varied. Like if I ask you what your favorite pizza topping is, I might get a variety, but I'm probably not going to get more than 10 or 15. And that might be enough. If I'm asking enough people, that's okay. I'm sure the number one survey answer on the board is pepperoni. And that's because most people just assume pizza comes with cheese. Not all pizzas come with cheese. So some people say cheese. I just prefer, cheese is my favorite topping. The last kind of entry, it doesn't take a lot of room. Type of bias that we were going to talk about is data entry errors. You're typing it in, or the person you're surveying types it in. They meant 19, typed 91. You can't do anything about it other than making sure you keep all, like if you're typing it in, keep them in, like if you've got them on like a piece of paper, you're going down a list, type them all in and then go through the list and match them up one at a time and make sure you did it correctly. That if it's someone else typing it in, like SurveyMonkey, you do a thing on SurveyMonkey, you send it out to people, they type in their responses if it's an open-ended question, or even if it's a closed question, they just might click on the wrong box, get distracted, miss. So it's kind of hard to avoid those, but they do exist. You can do what you can to minimize them by double checking all entries, stuff like that. Any questions on biases? All right, let's take a look at 1.6. So we kind of talked about the process of statistics, but one of the steps is conducting an experiment, and we didn't really talk about that. So 1.6 is about steps in an experiment. Because when you do a survey, that's just, you are doing an experiment. It just happens to be that you're asking questions to find the answer. Experiment. So step 1, identify the problem or question to be answered. And you should probably select or know the population that you're going to study. You're going to study. And this is what I mean by that. If I want to study all students, like students' opinions across the country, polling just COS students is a terrible idea. That's a convenient sampling. I don't have students from other states. I don't have students from large cities, Visalia and Tulare and Hanford. We're all maybe decent size, but we're not big by a long shot. I don't want to use LA or San Francisco is a good example, because San Francisco is on its own if you ignore the San Francisco Bay Area. San Francisco is a big town with a lot of people in it. The San Francisco Bay Area, or if you talk about Sacramento, when you say Sacramento, people are often including all the cities that are around it. Sacramento's got a lot of cities that are around it. Same thing with LA. We say Los Angeles, but basically, like anything south of the Grapevine, everyone calls the Los Angeles area. And it's not. Los Angeles is one city in Southern LA. So am I representing all students if I just ask COS? No. So maybe I shouldn't say I'm studying all students. Maybe the question should say students in COS students. Like maybe I should just target COS students, or students in the Tulare County. If I say that, I might want to ask West Hill students though too. So maybe I just say COS students. That way I'm picking my population, and my results only are going to be applicable to COS students, but other people might extrapolate to other areas or conduct the experiment in other areas and do it on a larger scale. Most students don't have the means to do that. So once you know what you want to study and who you're going to study it with, even if it's not people, if it's cars, if it's sampling chocolates to see how many, like if you work for C's Candy and you're sampling the chocolates to make sure none of them are, you want high quality chocolate across the board, they sample them and see if any of them are bad, kind of thing. Number 2, identify factors that affect the outcome. So maybe to do this here, I'm gonna pick that university question that we were talking about on Tuesday. Let's make our question, do Tulare County residents support an extension campus for a four-year university to be located near by COS Visalia with taxpayer money? Just asking if they say support the idea. Most people say yes. Are you willing to pay more taxes? That's another question altogether. So maybe we should make that our question, because that's what COS is going to be wondering right now when they that's what they're trying to get. They want a measure or a bill on the upcoming election to say, will you support it? That's how we have the Tulare and Hanford campuses. Taxpayers supported it because it's good for the community to have extra campuses, more spots for students to go, not have to travel. I think that's a good indicator that they will support it, because they supported building Tulare and Hanford campuses. But we got to ask, it's a new thing. It's a four-year university. We got to ask. So that's going to be my question. Now let's identify factors that affect the outcome. So parents with, well, I was about to say parents with children, but that sounds pretty stupid though. Because you have to have a child to be a parent. So let's say parents with college-age students or younger. Might be more invested in it. And people without children may be against it. Not so much against the idea of people in the valley getting a better education, but they may not want to pay taxpayer dollars for it. So they might be against it. What other factors might come into play about whether or not someone would be interested in this? Can you guys think of any?
The area where the campus could be built.
That's a good one.
Like invading a neighborhood or something.
Area where the campus will be built. I know the people that live near COS, they have to have signs saying you need to have some sort of permit or something like that to park on the street. Isn't that right? Or did they change that? They get tired of students parking up and down in front of their houses and leaving no room. Stuff like that. It may be louder with students walking around using your area. So yeah, I could very much see that. Any other ideas? That's a pretty good one. Well, if you think of any, let me know, and we'll add them to the list. I had location kind of in my head, but that's the only other one I could think of. Like you didn't, but you brought that up already. So let's go on to step C. Or C. I said step 1 and 2, and now I'm saying step C. Step 3. We want to determine the sample size. And frequently, this will be as large as possible. As time, money, and resources will permit. Later, in one of the later chapters, we will cover picking the good values. Like if for the COS thing, if there's 15,000 students, it doesn't really make a lot of sense to ask 7,000 students what they think. At that point, I already have half the population. I might as well just finish. So you don't want to ask too many. At one point, you're asking just too many. It's not helpful anymore. You've gone too far. You've used up too much time and resources to get it. But you're going to want to pick that before you get started. You don't want to just go to an unknown amount. If you can. Sometimes you do, but sometimes sometimes that's the response you're going to get. However many people I can get to reply. Because remember, we have those response and non-response biases. Getting people to answer can sometimes be a pain in the butt. So sometimes you might just go with however many we can get. Step 4 is called the control step or control group. What we want to do is fix one variable in place. For some things. Like back to the thing we were talking about with, does mini fridge cause obesity? Well, maybe we might do one group that every person in the group has a mini fridge. And we might also do a group where none of them have a mini fridge. That way we can control that aspect and see if because you got to be, just doing the mini fridge alone doesn't tell you how it compares to non-mini fridge. So you got to do both groups. So maybe fixing one of those, saying this group is only going to be mini fridge, this group is going to be without mini fridge, and going from there. The variable we're going to fix in place is usually not the one we care about the most. We're studying. In this case, the obesity problem, we want to know what we can do to lessen child obesity. That's the goal. In drug groups where they do placebo versus the drug, what they want to do is help heal people. So the control factor is, does this thing affect the outcome? The outcome is what we're interested in now. So the thing that varies the most, varies or changes the most, is usually what we're interested in. In the example with the fridge and obesity, if they have a fridge, that is a thing that is unlikely to change. It is unlikely that they are going to get rid of the fridge. They already have it. Why throw it away? If they're in a study, they shouldn't be getting a new fridge. So there's nothing changing there. The only thing that might be changing is whether or not they're gaining or losing weight. The same thing with the medicine. The group getting the drug isn't going to all of a sudden start getting placebo, and the group getting the placebo is not going to all of a sudden start getting the drug. That thing remains fixed. It doesn't change. So that's what I mean by fix one variable in place. Make something not change. That is a terrible way to say it, but that's what I mean. Fix or lock into position. There may be other factors that affect the outcome. Just like we talked about with the obesity in the fridge. We talked about diet, exercise, genetics, stuff like that. These other things affect it. But what we can do to help minimize those things is random sample. If we randomize our selection process well, the other uncontrolled factors will balance out, I'm going to say. Will balance. So if one group's got a couple people, youngsters that have metabolism issues, the other group probably is going to as well. Each group is probably going to have students or kids that have a good diet versus a poor diet. Some that exercise versus not exercise. So if we randomize it, we'll have those things kind of like both groups have it. So the effects of it kind of negate themselves. And then we can just focus on the fridge kind of thing. That's the idea there. Same thing with the medicine. And will this thing cure it? Does taking something like the positive effects of belief when you think you're taking a drug, is that enough? If it works on the placebo, the same thing happens with people taking like a cure for cancer drug. It's gonna, if you randomize the sample enough, that whole amount might balance out some, but also just natural recovery diet. Again, with medicine, diet and exercise does a lot. May not for cancer, but for other things it might do just quite well. So randomizing really helps with a lot of that stuff. Number 5, do we have any questions so far? I don't want to go too fast. All right. Oops. Number 5 is experiment. Do the experiment. Do the survey, run the test, whatever it may be, to collect your data. Once we have the data, we will numerically summarize results. And use techniques that we discuss later. To determine success or failure. Or, in other words, support or refute the idea. So we're going to summarize the data, and that's going to be step 6. We're going to test the claim. Test the claim problem or question that we did in step 1. And this part is called inferential statistics. And this is where we infer something about the population. Based on the sample evidence. Give you guys a second, then we got one more topic in this section, and then we're going to start chapter 2, where we'll have a little bit of math. And I'll show you how to use StatCrunch. If you have any questions, let me know. Otherwise, I will continue. Some other ways we can set up an experiment is called the matched pairs design. And we'll do this in several times throughout the semester. You pick 2 connected things. Or people. And one gets the cause and the other one doesn't. This can, if you do this well, it can work well. Like if you were a great one to do it with, if you can get it, is with twins, where they're genetically alike. And you, like, if you were testing something, and that might, like, if you're doing, does this diet or food stimulate physical prowess or strength? Does it make you smarter? Whatever you're trying to do, you give it to one, not the other. But you do it with a bunch of groups where you test it. And so you can have several different pairs in the sample where one of them is getting the cause. Let's say it's legal performance enhancing drugs kind of thing. And then you have them both like do whatever the activity is beforehand. One of them gets to take the drug, the other doesn't, and you see if there's how they are both afterwards. So siblings or twins works really well. Twins works great. Siblings is usually pretty good too. Spouses, you might randomize whether it's the male or the female, or in case of same-sex marriages, which person gets it, to try to make it randomized, not be a gender-based idea. But having spouses tend to have a lot of things in common. Same living location, same diet, shared income, Oftentimes they feel the same way about a lot of things, although that's not always true, but usually they do. We could be paired by location. Later in this semester, we'll see. That doesn't say location very well. I didn't give myself enough room. If we're checking hotels and we want to check hotel prices, and I want to compare like the Marriott versus what's another big hotel? Let's go small, like Traveler's Lodge. What do people prefer? It's kind of good to pick them across towns, a town that has both a Marriott and a Traveler's Lodge across the country. Because if you just focus on one town, you might getting skewed results that are local. But if you pair them by city, then people in like San Francisco may feel one way differently than Tulare and Visalia, stuff like that. So the location's pairing. Another good choice is before, in this category, is before after tests with the same person. Person or thing. Does meditating for 5 or 10 minutes each morning help you do better in school? That's not a good one, because you should get better in time without it. Let's see. Does doing a specific exercise make you better at a sport? Does playing chess make you smarter? Things like that. Something where you do an activity or take a drug or whatever it is, and you take it over a period of time and you compare yourself before and after. Does quitting smoking help with lung capacity? You can test lung capacity before, while you're smoking, and lung capacity after. That's a little hard because then you need people that are actually ready to quit and do quit at that time. But there's a variety of examples in that area. All right. Are you guys ready to start chapter 2? Chapter 2 is on organizing data.
Well, I have a question.
Yeah.
So basically, chapter 1 is just all about like survey questions and all that stuff, correct? Like just
Yeah,
like
how to set up a good experiment and survey well so that every other step after it is legitimate. If you
Okay.
don't have a good experiment or survey, everything we do for the rest of the semester means nothing because you've already fucked it up.
All right.
Yeah.
Let me make sure.
So,
Okay.
so that's why we cover that first.
Okay.
And I will bring those topics up throughout the semester, but it's always good to keep those in mind. So chapter 2 is on organizing data. I'll be doing 2.1 today. You know what? I'm going to stop this recording and restart it so I have 2 recordings for you guys. Stop recording. So it's